In this lecture, we're going to be playing with some of the HTL algorithms and really focus on the iterators that they support and need. And the goal here is really to experiment with the iterators we've had a chance to learn about. We're going to look at input iterators, output iterators, forward iterators, bidirectional iterators, and random access iterators here. And as we do this, please remember this iterator hierarchy. You can have input iterators that allow you to read stuff. We can have output iterators through which we can write back into our collection. We can have forward iterators which allow us to navigate forward through the plus plus operator. We can have bidirectional iterators that allow us to move backwards. Random access iterators are going to allow us to jump around with pointer arithmetic-like operations. For example, we can take an iterator and add a 5, and that's going to move 5 places away from the current location of our iterator. That's what we can do with random access iterators. Again, iterators are the glue that tie together containers and algorithms. Containers are going to provide iterators, and algorithms are going to be looking for those iterators. And we want this kind of thing to work with our box container, but in this lecture here, we just want to see some of the powers of these iterators. And once we understand the power of those iterators, we're going to build that kind of power into our box container class. That's the plan here. Now, here is a simple example of a find algorithm. This algorithm is going to be looking for a particular element in the collection. And this is something we can do here. We can say SDD ranges find, and I am using the ranges version of the algorithm, even if I am specifying the iterator pairs, because these algorithms in the ranges namespace are much safer. We had a chance to look at this. But what I really want you to focus on is the kinds of iterators this algorithm requires. And to find this information, we need to go to CPP reference. So let's go there. We're going to open our browser and we're going to say SDD ranges find. This is the algorithm here. And we're going to find an entry from CPP reference. I am going to use that. And please take a moment to look at what we expect from these iterators here. If we look at this, we're going to see that it's going to require an input iterator I. It's going to require something called the sentinel. This is something we use to check when we have reached the end of the container. You can really treat this as an end iterator. And we have T, which is the type that we store in the collection. And we have a projection. What we really want to focus on is this I and S, which is going to be the beginning and the end of our collection. You see that the find algorithm is going to take a beginning iterator, which should be an input iterator, and the sentinel is going to be something that we use to know that we have hit the end. So we kind of need an input iterator for the algorithm here. And an input iterator, if you even look at this concept, please note that STD input iterator here is a concept, and we can click on it to kind of see the requirements. And my bet is that it just needs to be read from. And you can see that there is another concept that this depends on that is called indirectly readable. If we click on this, we should see that it needs a dereference operator, and you can see that right here. So our find algorithm really need the iterators we provide here to be input iterators. We need to have the ability to read through them. This is the requirement here. And before we look at other examples, please note that we're going to be using this operator here to print vectors in an easier way. You already know this function. We have used it like 1,000 times now. And let's look at another example. This time we're going to be looking at the copy algorithm, which is going to be copying from a container and pasting into another container. So we're going to have our vector, which is called destination here. It's going to have the size of our source vector. Numbers is going to be our source here. And we can copy like we do here. We're going to specify the beginning and end in the source container. Then we're going to specify the beginning of the destination container. That's what we do here. But because this algorithm is going to be copying and pasting into our destination container, the destination iterator here needs to be an output iterator. We need to have the ability to write into the container through this iterator. And again, we can find this out through CPP reference. So let's go there. This time we're going to say std ranges copy, and we're going to see what we find here. And if you look here, you see we need an input iterator I through which we can read, just like we did for the find algorithm. And we need an output iterator which is incrementable so that we are able to move forward. But there is also a requirement for I and O to be copyable. So we need to be able to copy stuff because this is a copy algorithm. So this is a requirement here. And we have other versions of this algorithm, but it's really the same thing. Okay, so this is an example of how an output iterator can be used. We really need output iterator support for this destination iterator here, because the copy algorithm is going to be going through this to write into our destination collection here. Let's keep working on other examples. We also have an example here for the replace algorithm. And this algorithm needs to navigate through the container replacing stuff. So it really needs to have a ++ operator on our iterator. Again, let's go to CPP reference to find this out. This is the replace algorithm. So we're going to say std ranges replace here. And let's see what we find here. Okay, we have our algorithm here. We have replace. This is what we have here, and it's going to be using I as an input iterator. We have a sentinel, but we also have a bunch of requirements on these iterators here. And one of them is indirectly writable. Let's go in and find what we have in this concept here. And you see that it has the std forward concept. And if we look at this concept, I think it's going to have a requirement to have a ++ operator somewhere. So the point I am trying to drive home here is that the replace algorithm is going to somewhat need a ++ operator. And if you don't have it, then your algorithm is not going to work as needed. And we're going to see these things as we build iterator support for our box container class. Let's look at another example that is going to show the powers of bidirectional iterators. For example, we can loop around into our container backwards. We can do something like this, but we can also use the reverse iterator, which I think is going to need to move backwards, printing things or doing things in our collection. So it may need a bidirectional iterator. And again, to find these things out, you can go to CPP reference to look on your own. So another thing we're going to look at is the sort algorithm, which is going to need random access iterators from our collection. If we don't have random iterators, this is not going to work. And again, we're going to see this when we hit the point to build iterator support for our box container class. Now that you know these things, I think it is high time we went to Visual Studio Code and played with us a little more. Here we are in our working folder. The current project is Iterator Powers. We're going to grab our template files pretty quick and we're going to put them in place. And we are going to crack this open in Visual Studio Code. So let's do that right here. We are going to open our main CPP file and clean it up a little bit. Let's remove what we don't need. And we are going to include the algorithm header. Let's do that. We are also going to include vector because we're going to be using this a lot. And I think we can also include ranges because we're going to be using the ranges versions for our algorithm. And we're going to put in a simple function template, which is going to be printing out our vector here. Nothing complicated so far. The first thing we're going to do is to specify our source collection, and it's going to be a vector which is going to contain a bunch of numbers, nothing complicated here, and we're going to print it out. Once we use the output operator or the output stream operator on our collection here, the compiler is going to pick up this operator and use it to print our vector here. Let's try this out with one of our compilers. We can use GCC because it is my favorite. Let's see how this goes. We can bring this down a little bit. And the build seems to be good. We can bring up a terminal window. And we're going to try and run this. If we run Rooster, we're going to see it's going to say the numbers that we have in our collection here. So everything seems to work. The first thing we're going to do here is play with the find algorithm. And we're going to put a comment here to say what we want. So the find algorithm really expects to have input iterators through which we can read but we don't really need to have any other support. For example, output iterator, forward iterator. It just needs to have a dereference operator through which we can read, and that's what we need here. So we're going to use this to find an 8 in our collection. If we find it, we're going to land here and say that the collection contains 8. If we don't find it, we're going to say that it doesn't contain here. But notice that we are using constant iterators through which we can't go to write back. And I really wanted to use this to drive the point home that this is just an input iterator through which you can read. And that's the requirement for a defined algorithm here. Let's pass this through the compiler and see what we get. It should work. And again, notice that we are using the ranges version for the algorithm to be able to have the protection that concepts give us, because we know that these ranges algorithms are constrained with concepts here. Seems the build is good, so we can pass this through our, let's run this. So we're going to see that numbers does not contain 8. And if we go, and we're going to see that we don't have 8 in here. But if, for example, we change this 7 to be 8 and build again, we're going to pass this through GCC. The build should be good. If we clear and run Rooster, now we're going to see that numbers contains 8. And this is a good example of an algorithm that only requires to have input iterator support. Let's comment this out because we still have a few things we can look at. We are going to go down and put in an example that uses the copy algorithm. The copy algorithm is going to need to read from the source collection, which is our numbers here, and it needs to write through the destination iterator that we have here. And the destination iterator needs to have a ++ operator. I think it's needed by the copy algorithm here. Now you see that we have a problem. We have a squiggly line, and that the reason is we specified a constant iterator as the destination iterator here. And this is a problem. The algorithm needs to go through this iterator, the iterator we have right here, to write back into this destination container. But because it is a constant iterator, the algorithm can't really do this. So for this to work, we need to make this a non-constant iterator through which we can go to write back into our destination collection here. If we make this a non-const iterator, you're going to see that everything is just going to flow in place. Let's pass this through the compiler. The build is going to be good. We can clear and run Rooster. We're going to have our source container, which is 1 through 89 here. And we're going to print this collection again. We're going to print the destination. And then we're going to print the source again and print the destination. You see that the data has been copied and pasted into our destination container. But for the source collection iterators here, we don't need output iterator support. For example, we can change this to cbegin and cend, and you're going to see that the algorithm is going to work because we don't need to go through these iterators to write back into our collection. I really want you to see this. Let's pass this through the compiler again to make sure this works. You see the build is good. We can clear and run Rooster, and it is going to work without a problem. But the moment we make the destination iterator here a const iterator, then everything is going to break down. We're going to have a bunch of compiler errors. And let's look at the compiler error, because I think concepts should give us something nicer to look at here. And we kind of need to sift through the errors here to see what kind of concept we are not satisfying. But one thing we're going to see is that the dereference operator here is not working for our output iterator that we specified in this place here. I think this should be very clear. We need a dereference operator through which we can write to make things work. And if we make this a const iterator, that's not going to work. Let's turn back to be a non-const iterator. And if we build again, we're going to see that this is going to work just fine. The build is good. So let's try and run this again. And this is going to work. Okay, now that we have this in place, I think we can comment this out and look at another example of how we can do things through our iterators. The next thing is going to be the replace algorithm, which I think needs a ++ operator. So let's look at here. We're going to loop through the containers, replacing every instance of 7 with 345. Let's go back and see if we have a 7 somewhere. Let's put that back in here. And let's build and see if this actually works. We can build with our GCC compiler, which is my favorite. So the build is good. We can clear and run Rooster. And we're going to have the source collection, and we're going to see that the 7 here was replaced with the 345 that we have right here. Okay, so hopefully this is a good example of why we might need a forward iterator, because for this algorithm to work, we will need a plus plus operator. I think if you go back to CPP reference, we're going to even find possible implementations for many of these algorithms. This is a good example for the replace algorithm, and down here you see that it's going to be looping around using the plus plus operator, and if it finds a value worth replacing, it's going to replace that, and we need the reference operator for this to work. You can see a good example of this algorithm here, and it is really wrapped into a bunch of functors. I think this is how the C++ standard library does this. But we don't need to worry about this. We just want to use these algorithms here. Okay, now that we have this in place, I think we need to look at an example of where we might need a bidirectional iterator. Let's go down and save that. And we're going to put in a piece of code I had prepared before. So we're going to be needing the ability to loop backwards and print our collection. We can do that right here. And this is the loop that is going to do that. But I also think that the reverse algorithm is going to need the negative incrementation operator to move backwards. So let's look at the reverse algorithm here. I think we can do that. We're going to say std ranges reverse. Let's see what we get here. And we have the algorithm here. Let's click on it. std ranges reverse, and if we go down, I think we're going to have a possible implementation for this, and you see that it's going to be using minus minus on our iterators here. So this needs a bidirectional iterator. This is the point I am trying to drive home here. If we try to build, let's see if this actually works. The build should be good, and if we clear and run Rooster, we're going to be printing our numbers in reverse through the loop here. I think this is what we see right here, and we can even go through the ranges reverse algorithm to reverse our collection, and if we do that, we're going to have this printout here. So this is going to work. Notice that we are just specifying a range, but even if we specified an iterator pair, this is going to work. So if we do begin and numbers, and I think this is also going to work because the ranges algorithms also support iterator pairs. This is going to work. If we clear and run Rooster, this is going to work just fine. Okay, we still have one more example before we close up this lecture here, and we're going to be needing to play with random access iterators. And one good example for random access iterators is the sort algorithm. So we're going to be sorting our numbers and printing them again. But if we go to CPP reference, let's look there. We're going to say std ranges sort, and we're going to look at the documentation for this. We're going to see that it needs random access iterators, right? This is the first thing we see here. And if you go down, we're going to find a possible implementation. Sorting is not a trivial thing, so the algorithm here is a bit complex to understand, but that's not the point of the course here. We just want to be able to use these algorithms in our collection. Now that we have this in, we can build our program here. Let's pass this through GCC, our favorite compiler. The build is going to be good. We can clear and run Rooster, and we're going to see that our thing is going to be sorted out here. This is really all I wanted you to see in this lecture, showing you a bunch of algorithms that use different kind of iterators. And now that we know this, we're going to try and see how we can make our box container support these cool algorithms from the C++ standard library. So we want to go up and replace this vector here with our own box container, and we want the code below here to work. This is what we want to do, and we're going to start and see how to set this up starting in the next lecture. So go ahead and finish up here and meet me there.